10.5 day 2, we're going to take a look at two problems again where we're I don't have it written out, but we are eliminating the xy term by rotating the conic. And then we'll write it in standard form and possibly graph it. So here's our first one, and here's a second one, just giving us some more practice with this. And day 1 we spent, I think most of our problems we always had an angle of pi over 4, so we used 45 degrees. So we always have the same substitution. You kind of get in the rhythm of doing it, which is good. Now we're going to run into problems where it's not going to be 45 degrees, and then how do I go about doing it? So start your problem the same. It asks you to eliminate the xy term, so I want to start by doing the cotangent of 2 theta is equal to, and then it's a minus c over b. So a is the number in front of x squared again. Excuse me. Minus c, the number in front of y squared, divided by b, which is the number in front of the xy term. And so simplifying that, I can see it's going to be 6 over 6 square roots of 3, or that's going to simplify to this. Or if I want to rationalize it, I could. Now, this is something, when I see a square root of 3 like that, it's something I should recognize on the unit circle. Imagine if you divided both of those numbers by 2. Remember, as long as I do it to both of them, I'm not changing the number. And remember, this is cotangent, which means it's x over y. So that means the x value is 1/2. The y value is the square root of 3 over 2. Think on your unit circle, where do you have an x value of 1/2, a y value of a square root of 3 over 2? That's 60 degrees. Now careful, because I'm not actually rotating 60 degrees. That means 2 theta is equal to 60 degrees. Or if you were using radians, you'd say pi over 3. So I would be saying that 2 theta is equal to pi over 3, which realistically means my angle of rotation is actually pi over 6, or 30 degrees. So be very careful with that. Alright, so I can move forward now. My substitutions would be x is equal to x prime times the cosine of 30 degrees, or pi over 6, minus y prime times the sine of 30 degrees, or pi over 6. And like I said before, get in the habit of writing this out, this first step. Even though you eventually are going to know it, it's nice if you write it out. It just helps you to kind of memorize this. My y substitution would be y is equal to x prime times the sine of pi over 6 plus y prime times the cosine of pi over 6. And then if I go ahead and actually figure this out, I am going to end up with x is equal to cosine of pi over 6, or 30 degrees, that's the square root of 3 over 2, x prime, minus the sine is 1/2, y prime. And then my y substitution is, y is equal to sine, which would be 1/2, x prime, plus cosine now is square root of 3 over 2, y prime. And so there are the substitutions that I need to have. Alright, so I've got my angle of rotation, 30 degrees. I've gotten my substitutions completely simplified. And now remember, I'm going to take this, and wherever I see x or y, I'll replace it with the primes. So when my problem says 13x squared, I'm going to start by saying 13 and then put this squared. So it's now square root of 3 over 2 x prime minus 1/2 y, quantity squared. That takes care of the 13x squared. Now I've got plus 6 square roots of 3 times x, which is square root of 3 over 2 x prime minus 1/2 y prime. There's x, times y, which is 1/2 x prime plus the square root of 3 over 2 y prime. Plus 7y squared, so 1/2 x prime plus the square root of 3 over 2 y prime, there's y squared, minus 16 equals 0. And so now I've got the equation written out where I no longer have x's, I have x primes and y primes, which all that means is that I'm on the rotated axes. Algebraically, I'm not going to really do anything differently. I'm going to solve. Now I'm going to go ahead and multiply or FOIL this out. Again, if you need to see the 2 sets of parentheses for this, please write them out. Alright, so leave the 13 alone for now. So squaring this, that means I would be squaring this term, which if I square this term is going to give me 3 over 4. So it's 3 over 4 x, and you can stop doing the primes now just to basically be convenient so I don't have to put the parentheses around it. So it's 3 over 4 x squared. To do the insides and outsides would mean I would multiply these two things together twice. So that would give me negative 3, it would be negative square root of 3 over 4, and then another negative square root of 3 over 4. So that would give me negative 2 square roots of 3 over 4 x, y. Now you're probably saying you can simplify that, and yes I can, and if you want to simplify it, go ahead. I'll just leave it with the 4 in the common denominator because they're all going to have 4 as a common denominator, but yeah, you can obviously simplify that. Alright, that's the insides and outsides, and then the last would be multiplying that by itself or squaring that. So that would give me 1/4 y squared. Alright, so there's that parenthesis foiled out. Multiplying these together, keep the 6 square roots and 6 square roots of 3 in front. Multiplying these together, you are going to end up with a square root of 3 over 4 x squared. Doing the insides, I get negative 1/4. Outsides, I get positive 3/4. So positive 3, negative 1, that's going to give me a positive 2/4 x, y. Again, I can easily simplify that down if I want to. I'm leaving it because they'll have the same denominator here, and it just makes it easier when you go to simplify. And then the last, when I multiply those together, I get negative square root of 3 over 4 y squared. Again, if you're not getting the same thing I am, then you might want to back up and redo this. Possible I made a mistake. We'll find out here in a second. All right, plus 7, parenthesis, again, squaring this. Remember, you have to FOIL, even though I don't have the two sets of parentheses. Squaring this term would give me 1/4 x squared. Insides and outsides would both give me square root of 3 over 4, so I'll have a total of 2 square roots of 3 over 4 xy. And then when I square the last term, that's going to give me 3, if I square this, over 4 y squared. And then I can say minus 16 equals 0, or I know from previous day that eventually I'm going to have to move that 16 over to the right side. Alright, now I've got it all multiplied or FOILed out. My last step would be to go ahead and distribute the 13, the 6 square roots of 3, the 7, whatever the case may be. And so if you need to have a calculator handy while you're doing this, that's by all means fine, but most of these I think we can multiply out just fine. So it's 39/4 x squared. It's going to give me negative 26 square roots of 3 over 4 xy. Again, I'm ignoring the simplifying. Plus 13 over 4 y squared. There's what I get if I distribute the 13 through. Now multiplying by 6 square roots of 3, that's going to give you 3 times 6, or 18. So plus 18/4. Again, I'll worry about simplifying later. Here, it's going to give me 12 square roots of 3. So positive 12 square roots of 3 over 4 xy. Here, again, that'll turn into 3. This is going to be negative now. 3 times 6, or negative 18 over 4 y squared. Distribute the 7, I get positive 7 over 4 x squared. I'm going to get 14, positive 14 square roots of 3 over 4 xy, and a positive 21 over 4 y squared equals 16. Once you finally have everything multiplied out, this is kind of your moment of truth, or this is when you can check to see, am I on the right track? Remember what we said about the xy terms. They all have to cancel. If they don't add together to give you 0 or cancel out, you did something wrong. And it could be that angle, it could be these substitutions, or it could be you just multiplied and have a plus or minus sign somewhere in the wrong spot. And if we add all these together, this is negative 26 radical 3 over 4. This is positive 26 radical 3 over 4. Sure enough, they do cancel. If they don't cancel, kind of a rule of thumb, look at them. If let's say I had a negative here, and I looked at this and I said, well, man, if that had been positive, they would have canceled. It's probably something as simple as you missed your sign. If it's not, then you got to go back and try to figure out what it is. Hopefully it's not this angle, because that means you're going to have to redo everything. And I know that can be extremely frustrating, but please go back and redo it. It's good practice. All right, now I get to go ahead and add like terms together. So here's an x squared term, here's an x squared term, another x squared term, and I'll add all those together. ignoring the numerator, I've got 39 over 4, I've got 18 over 4, and I've got 7 over 4. And if I add all those together, that would give me 64 over 4x squared, or of course I can just say that that's 16. So it most of the time will work out nice like that. Not always, but a lot of times that will work out and happen. Then look at your y squared terms and do the same thing. I have 13, subtract 18, and then I'm going to add 21. And this is going to give me 16 over 4, or of course that's just 4y squared equals 16. So it ends up working out really, really nice. And then of course I've got an ellipse. I don't want this to be 16, I want this to be 1, so I'll divide everything by 16. That's going to give me a 1 in the denominator for the first term, so it's going to just be x squared over 1 if you want to put it there. Plus, that's going to be 1/4, so y squared over 4 is equal to 1. And so there it is in standard form. Now remember, there should technically be primes on the x squared and the y squared. We just decided to leave them off, which is fine if you want to do that. Alright, so that's kind of the hard part, the battle. If you can get through a problem like that, even if you say you have 3 or 4 of them on the homework and you get through one but you make mistakes on the others, you probably have the right idea. It's just easy to make little mistakes on this. Try not to get too frustrated. Alright, in terms of the graphing, again, we're just going to kind of rough sketch it. Here's my x and y axes. The x prime, y prime, now I'm not going to rotate 45, I'm rotating 30. So you're just going to kind of approximate that. I think that's about there. We don't need to be exact. And rotate that 30 degrees, that 30 degrees. If you want to, you can say, you know, this is pi over 6 or 30 degrees. That might be nice. I don't necessarily need you to do that. And then remember, we'll just kind of tilt the axes. We'll put tick marks on here. This is not going to be exact, and it's not exactly the way the book wants you to do it, but it will get us an accurate enough graph. And the way the book wants us to do it is just going to take a little too long, so we'll do this to speed it up. Alright, so I know it's an ellipse. I know the center is 0, 0 according to this, so I've got 1 point here at 0, 0. And then according to this, I have a 1 in the denominator. Square root of 1 is 1, so go right 1, left 1. So go right 1, put a point, left 1, put a point. Denominator here is a 4, square root of that is 2. Go up and down because it's y. So up 2, down 2, and then this is an ellipse because they're both positive, so now I just have to draw the oval. And there it is. Looking at it this way, there is my graph. Overall, the graph isn't as important, although that should be the easiest part of it. Getting to that is what's really important. And you can see there's a lot of algebra in there. Having to multiply or square that, having to multiply those together, easy to make a little mistake. So again, try not to get frustrated. Alright, so last one for practice. And this one is important to look at too. This one worked out really nice. It was something I recognized on the unit circle. You're going to see for this last one, I'm not going to get something I recognize on the unit circle, so what do I do? And if you have your notes sitting next to you, you can see that we did one like this. So I'm going to have the cotangent of 2 theta is equal to 16 minus 9 over negative 24. Or if I simplify that out, that's going to give me 7 over 24. And yes, it's negative. Now, one thing you need to remember when we were talking about it yesterday, we talked about it in class, we said if you have one of these numbers as being negative, make sure that you put it on the x. Cotangent kind of restricted to the top 2 quadrants to rotate a positive direction, so make sure you put the negative on the x. That's going to throw off the work if you don't. If they're both negative, of course, it just cancels and it's positive. Now, I don't recognize that on the unit circle anywhere, so what I can do, and I can actually do it back here, and I'll come back and show you that I could have done it, is I'm going to draw a right triangle. So, I'm going to draw a right triangle. I can see that that's a negative x value, so like I always ask you, please draw your triangles that actually looks like it's in the right quadrant. Here is 2 theta. My x value, because it's cotangent, is on top, so it's negative 7 for the x value, 24 for the y value, and you can quickly run through your Pythagorean theorem if you would like to figure out what the hypotenuse is. Eventually you're going to need to figure it out, and you might remember this is one of your Pythagorean triples. It's a 7, 24, 25 triangle. Alright, so now I've got this triangle. Now remember, this is 2 theta. So when I go to my substitutions and I say, oh, the cosine of theta is negative 7 over 25, that's not right because that's the cosine of 2 theta. You have to use 2 other formulas, and this is one of them. the cosine of regular theta is equal to the square root of 1 plus the cosine of 2 theta, which would be this triangle's cosine, divided by 2, and that's all under the radical. So the cosine of regular theta, which is what I'm looking for, is equal to the square root of 1 plus negative 7/25, so minus 7/25 divided by 2. And calculating that out, that's 25 over 25 minus 7 over 25, and that should end up giving me 18 over 25 over 2. Now remember, you're multiplying by the reciprocal, so the 1 would go up with the 18, the 2 would go in the denominator with the 25, and I would actually simplify and say it's, if I write it like this, I would actually divide the 2 and the 18 out so that it's 9/25. And we get really lucky here. Look how nice that is. It's a fraction. It's simplified. I can take the square root of each of those separately, and it actually works out very nice. Now, when we did one in class, we said that if you got something like this, I know this didn't happen, but if you had gotten something like this, we said to leave it unrationalized. It'll actually make the process of going through all of this and foiling easier if you do that. You don't have to, but that's what I would recommend. All right, we don't have to worry about it here. There is my cosine. So there's the cosine of theta. Now I need the sine of theta, and it's almost the exact same equation. The only difference is it's 1 minus cosine 2 theta over 2. So you've obviously got this formula that you're going to want to try to remember or memorize. You're going to need to know when to draw a triangle, when you can just use unit circle stuff. You can always do this triangle if you're not sure when to use unit circle stuff. And then you're going to have to memorize these two formulas so that you can actually figure out what the sine and cosine are. Alright, so continuing to calculate this out, this is going to be 1 minus a negative 7/25, so plus 7/25 over 2. Now it's 25 over 25 plus 7, or 32 over 25 over 2. And again, if you multiply by the reciprocal and simplify, that would be 16/25. And again, we get really lucky because both of those are perfect squares and we end up with 4/5. If by chance you did have a square root of 5 in the denominator, like I said before, leave it unrationalized. So here are my substitutions. X is going to equal x prime times the cosine, which is 3/5. So it's 3/5 x prime minus y prime times the sine, so minus 4/5 y prime. And the y substitution is x prime times the sine, so 4/5, plus y prime times the cosine, so 3/5. And there are the two substitutions that you're looking for. And now, of course, your job is to take these substitutions and plug them in for all the x's and y's that you see. So doing that, I'm going to end up with 16x squared, which here's x, 3/5 x prime minus 4/5 y prime, squared, minus 24xy, so minus 24, x is 3/5 x prime minus 4/5 y prime, y is 4/5 x prime plus 3/5 y prime, plus 9y squared, so plus 9 times y, which is 4/5 x prime plus 3/5 y prime squared, minus 60x, so minus 60 times 3/5 x prime minus 4/5 y prime, minus 80y, minus 80 times 80 times y, which is 4/5 x prime plus 3/5 y prime, and then I'm going to say that that equals negative 100. Alright, so got it all written out. Now I get to go through and multiply or FOIL everything together, or distribute. So if you need a calculator, again, by all means you can do that. Otherwise, I think most of these you can probably do in your head or you'd show by hand if you needed to. Make sure that you FOIL this out before you worry about the 16. So it's going to be 16 parenthesis. FOILing, again, remember it's two sets of parentheses, so write them out if you need to. Squaring that term is going to give me 9/25 x squared. Multiply the inside, so multiply these together gives me negative 12. Outsides would also give me negative 12, so negative 24/25 y squared. Squaring this term would give me positive 16/25. Whoops, that should not be y squared, that should be xy. This should be y squared. There we go. Alright, minus 24 times, first would give me 12 25ths, x squared. Insides would give me negative 16, outside's positive 9. So inside's negative 16, outside's positive 9, should end up giving me a negative 7 over 25 xy. And then the last looks like it's going to give me negative 12 over 25 y squared. Alright, plus 9 times, foiling this, if I square the first term it would be 16 25ths x squared. Insides and outsides are both positive 12, so adding those together I get positive 24 25ths xy. And then squaring the last term will give me a positive 9 25ths y squared. Need to distribute the 60 here, so that's going to give me negative 180 over 5. Again, I'll worry about simplifying this at the end. X, just x. Distribute here, I get a positive 240 over 5 y. Distribute here, I have 8 times 4 or 32, so add the 0 on. That's going to give me minus 320 over 5x. And then distribute negative 8 times 3 is 24, add a 0, so negative 240 over 5y equals negative 100. Alright, so now let's go ahead and distribute the 16, the 24, the 9, and so on. Now you probably see right here that these actually cancel. That's really nice. Alright, so distribute the 16. So at this point, if you need to use your calculator, go ahead and do so. Alright, so that's going to give you 144 over 25x squared minus 24 times 16 is going to give you negative 384 over 25 xy. 16 squared, you might know what that is. It's 256. If not, no big deal. Over 25 y squared. If it kind of helps to do something like this to separate your steps, you can obviously do that too. Alright, here I've got negative 24 times 12. That should end up giving me negative 288. So minus 288 over 25 x squared. It's going to end up giving me a positive 24 times 7, which is 168 over 25 xy. And that's going to give me a positive, if I multiply 24 and 12 together, 288 again over 25 y squared. Distribute the 9, and 9 times 16 should give you 144 over 25 x squared. 24 times 9 should end up giving you 216 over 25 xy, and positive 81 over 25 y squared. We already canceled these, and it looks like if I subtract them I get negative 500 over 5, or I'll just say negative 100. X is equal to negative 100. Alright, now is kind of that moment of truth. So we've done all this work and we hope like crazy that this is all going to cancel out. There's an xy term, there's an xy term, and here is another xy term. So now I'm going to go ahead and take 168, add to it 216, and sure enough, we get lucky. It actually is 384, so we did this correctly, thankfully. Alright, so I can cancel those out, and now I'll start adding like terms together. And like I said, excuse me, most of the time these things add together quite nicely. Not necessarily always. What do you notice happens here? 144 is 288. They completely cancel, which happens sometimes. That's not a big deal. Here's a y squared term. Here's another y squared term. There's another one. So take 256, add to that 288, add to that 81, and you should get 625 25ths y squared, which of course is the same thing as 25. So I'll kind of show two steps at once here. That's just 25y squared. I still have that negative 100x, and it still equals negative 100. So if you can get everything to work out the way it's supposed to and cancel, turns out that it works out really, really nice. Now I hopefully recognize this is a parabola, one squared term, a non-squared term. Remember what that should look like. The squared term, I'll just use y since it looks like y's got the squared term, should look something like this. The 4p number should be in front of the other parenthesis. So there should be nothing in front of the squared term, so that 25 is going to have to go away. Now yes, obviously I can divide it right now by 25 if I want to. That's kind of up to you. So I'm going to leave the squared term on the left. I know that I do not have to complete the square. I've got a y squared, but I don't have a regular y. I'm going to move the 100x over to the right. And then if you want to divide by 25, you can do that right now. I'm going to wait till the end. Doesn't matter when you do it. Probably be smarter to do it right now, but I'll wait till the end. Remember that you need a set of parentheses like this because you need to know what that number is. So whatever this number is, factor it out. They happen to have it in common, which obviously makes it a lot easier for us. And now if you haven't done so, you're going to have to divide everything by 25 because you need this to be just y squared. So now I've got y squared is equal to, that'll give me a 4, and then x minus 1. And there it is in standard form. And so now when I go to do my graph, and here's my x, y system. The only trouble I'm going to have with this, because you said you're going to be doing this without a calculator, is I don't actually know what the angle of rotation is. Like I didn't actually figure out what theta is like I did on the other problems, so I really don't know. If you have a calculator handy, I can figure it out. So for example, let's say I took this. This cotangent is equal to negative 7/24. That means that the tangent of 2 theta is equal to negative 24/7. And I change it to tangent because I have this on my calculator. I can do second tangent negative 24/7, hit enter. And then I'm going to have to recognize that again because it's tangent inverse. The calculator thinks I'm in the 4th quadrant. Really, I'm in the 2nd quadrant, so add 180 to it. That is what 2 theta is. If you divide that by 2, there is your actual angle of rotation, 53.13 degrees. Now, all I'm trying to figure that out for so I know how to rotate this axis. If this was on the test and you were graphing it, you can basically just say, you can just do something like this and say this is the angle of rotation because I'm going to know that there's no way that you can find it. Alright, so we're rotating 53 degrees. You don't have to be exact. On the homework, I think you can be, you can at least write it down so I know what you're rotating. Alright, and then go ahead and make your tick marks if you need to. So, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so on. And then graphing this parabola, looks like the vertex point is positive 1, 0. So positive 1, 0 is going to put me right here. And then I can see this parabola is opening to the right. It's y squared, so it's right or left. That's a positive number, so it's going to the right. And then p, remember 4p is equal to that number, so divide both sides by 4. P is going to equal 1. So since it's opening to the right, my focus is here. Not that I really need the focus, but my focus is going to be here, and I'm opening to the right. And there's my parabola. Looks like a parabola had been opening to the right. If you rotated it 53 degrees, it would look something like that. And that'll be accurate enough. Alright, 2 problems that took probably a lot longer than you thought they would, but they're a very good practice. Make sure that you are asking for help if you need to with that section.